Okay, good morning. You're welcome to today's class. We're going to study on polynomial functions. And then it's in parts. So this is part 1 of polynomial functions. Let's begin. First of all, if you haven't subscribed to this channel, do so. And the channel is Maths for You. Here we study mathematics every day. Okay. All right. Let's proceed. Let's proceed. So we have phase 1. That's going to talk about the types of polynomial functions we have. Now, a function of the form f at x equals to ax plus b is called linear function. That's the first type of polynomial functions we have, linear functions. Okay, good. And they have the form f at x equals to ax plus b. Also, a function of the form f at x equals to ax squared plus bx plus c is called a quadratic function. So now, when the coefficients of ax squared plus bx plus c, that is the coefficient of x squared being a is greater than 0, then we're going to get what we call a minimum value. And when a is less than 0, we will get a maximum value. Now note that a is not equal to 0. This is because when a is 0, then that function becomes a linear function. Also, a function of the form f at x equals to ax cubed plus bx squared plus cx plus dx is called a cubic function. Yeah, let's go ahead. To phase 2. Here we're going to talk about the graphical and other properties of these polynomial functions we have stated. I mean, the types of polynomial functions we stated. The linear functions, the quadratic functions, the cubic functions. We're going to look at their graphical and other properties. So let's talk about linear functions. Linear functions are always straight lines. They are straight lines. Those lines are not curved, they are not bent, they are simply straight lines, okay? And so when the coefficient a is greater than 0, this is the type of line we have. And also when it is less than 0, then we have this line. So when it is greater than 0, the line is called a positive line, okay? And then when it is less than 0, the line is a negative line. All right. Negative and positive simply because as we go ahead in graphing, we will come to understand that when a is greater than 0, you're going to get a positive slope. And when a is less than 0, you're supposed to get a negative slope. Next, talk about these quadratic functions. Now, every quadratic function is a bell or U-shape. I believe you've all seen a bell or how to write U, okay? So that is the shape of quadratic function. That's the shape it takes, a bell shape or a U shape. We'll look at some more practical on this. So a typical example is what I have there. And this curve is a U shape or a bell that is turned upside down. Is that okay? Now, it is this form or it is in this form when a is greater than 0. So it means when the coefficient of x squared is positive, then the curve will become the U shape. And then when the coefficient of x squared is less than 0, then we will get the bell shape. Is that okay? Now the line cutting or dividing these shapes is called a symmetric line. Is that okay? Let's go ahead and get to know. Now these two curves are called parabola. So if you're asked to sketch a parabola, this is the shape it takes. Is that okay? It takes the shape. The axis of symmetry, that is x equals to negative b over 2a. So the line of symmetry we have there, if you want to find the exact point that axis is going to be, you have to use the x equals to negative b over 2a, where b and a are the coefficients of ax squared plus bx squared, ax squared plus bx plus c. Is that okay? Yeah. Now let's talk about cubic functions. Yes. Cubic functions also is a continuation of these quadratic functions. Is that okay? So with the quadratic, it only ends at the u. Yeah. But with cubic, it has both u and then a bell shape combined. Is that okay? Just that we are able to tell why um we are able to tell either it's going to start from here and then go like that, or the other way around. Yes. So you see these two shapes. Yeah. Now, when the coefficient of a is positive, that is greater than 0 in a cubic function, then it takes this shape. This shape. Is that okay? And when it is less than 0, then it's going to take the other shape. Let's pause on this and then have a critical look on what we were really talking about. Okay, so now let's type in some functions, starting from the linear function. We said it takes the form f at x equals to ax plus b. So it means we said a is always a coefficient and it's a constant. Is that okay? It's a number. Is that okay with it? So let's say we have 2x plus, let's say 5. Now, if you could recall, we said when a is positive, what line are we supposed to have? This is the line we're supposed to have. Is that okay? So that line is always called the positive. This line is going to give us a positive slope. A positive slope. Is that okay? A positive slope. Now, what happens if a is negative? Let's negate it. You see? La la, there you are. It now becomes the opposite of what we had. Is that okay? So if we find the slope of this line, it's supposed to give you a negative slope. Perfect. Let's continue to the quadratic. Quadratic takes the form ax squared plus bx plus c, where a, b, and c are coefficients and they are all constants. They are numbers. So we say constant remain numbers. Is that okay? So let's pick an example. If we have 3x squared, sorry, let's use the calculator itself. 3x squared, yes. Now, even without adding the rest, you can see the shape it is given. Is that okay? Look at the shape it's given. This is what we looked at earlier on. Let's add the rest, and then we have plus, let's say, 5x minus, let's say, 3. So if we have a function that is quadratic and a is positive, which is 3 over here, then we are supposed to have the shape like this. Is that okay? Now, what happens if a is negated? I mean, 3 is negated. Let's see. Ooh. So once 3 is negated, see what happens to the function. It's now turned. It comes upside down. Don't come. Is that okay? Perfect. Let's now look at the final type that we were talking about. That is cubic function. Is that okay? So let's say we have a function x cube. Sorry, let me deactivate this. Okay, we have x cube plus okay, so the moment we have x cube, look at even how it looks like. Look at how it looks. Let me zoom it a little. Sorry. Okay. Now let's continue. So we have plus let's say 2 x squared. Okay. And then minus x plus, let's say, 5. Yes, there you are. So look at this graph. So looking at it, we see a typical look of the cubic function. Is that okay? Yeah. So that is how these graphs looks like. Let's proceed. The phase. So continuing with phase 3. Phase 3, we're going to talk about quadratic functions. Is that okay? Quadratic functions. So linear functions, we'll talk about it, but we have to focus on quadratic functions from now. Now we have met different methods of solving quadratic functions. Yeah, different methods for finding or solving quadratic functions or quadratic equations. Is that okay? So we have functions and we have equations. All right. If you have watched the previous video, you understand that. So the first method we have is called the method of factorization. All right. So the quadratic function has the general form ax squared plus bx plus c equals to 0. So this is a quadratic equation, not a quadratic function. Ax squared plus bx plus c equals to 0 is a quadratic equation and not a quadratic function. Perfect. If it was a quadratic function, it should have been f at x equals to ax squared plus bx plus c, or y equals to ax squared plus bx plus c. Those are functions. But talking about quadratic equations, that means it should be equal to a number, a 0 or something. Okay. Let's look at the steps in factorizing when we have quadratic equations. First of all, we have to find AC. So AC is just multiplying 8 with C. Is that okay? So you find the coefficient A or the constant terms A and then C, and then you multiply them. Secondly, we find factors of AC that sum up to B. So we're going to find factors of AC. So let's say if you multiplied AC and you had let's say if you had, let's say, 3, then you have to make sure that if you've multiplied AC and you had 3, so that means let's say A is 1 and then let's say C is 3. So we have to find factors of 3, okay, that will sum up to give us B. So whatever your B will be, you have to make sure you find numbers that when you sum them up, they will give you 3, and when you multiply, you get back your AC. That's what we do in step 2. And now, step 3, we substitute the factors in place of B. Is that okay? Perfect. Finally, we factorize and evaluate. That's all. Very simple. We will use some examples to explain this further. Let's look at the second method. We have method of completing the squares. Wow, very interesting. This was what was used in finding or generalizing what we call the almighty formula you have all heard about. Okay, we'll talk about that too later. Same equation, ax squared plus bx plus c equals to 0. The steps. Step 1. Now, we have ax squared plus bx plus c equals to 0. All right. Now, we factor out a, and when that is done, it means we're going to have a outside, and then x squared plus bx over a plus c over a. This is simply because when we multiply through the expression in the brackets with a, we are going to get back our ax squared plus bx plus c. Is that okay? Good. Let's go on to step 2. Now, step 2, we find half of bx over a. So it is b over a, right? So we find half of it. Half of it is going to give us b over 2a. B over 2a. And having b over 2a, we now square it. Now, when you square it, you make sure you add it to what's in the bracket and subtract it to what's in the bracket, as I have done over here. So we're going to have a in brackets, ax squared plus bx over a, as we have here, then plus b over 2a squared. Is that okay? Because we took b over a, we halved it, which gave us b over 2a, and then we squared it. That gives us b over 2a all squared. So we add that and then subtract that. Is that okay? So adding and subtracting, mathematically we call it create and destroy. This is going to cancel out this. Is that okay? But we do that for a particular purpose, which you understand. Let's go on. Step 3. After doing this, we realize that we have bx over a. We have b over 2a over here. Is that okay? Good. So we factor out them and then we square. So that we're going to have our a outside. We have x plus b over 2a all squared minus b over 2a squared plus c over a. Is that okay? So as you can see, we have squared, this is not squared. So we wanted to complete the squares. That's what we've done. And then finally, if you have to compute the last part, that is negative b over 2a squared plus c over a. If you have to compute that very well, you get b squared minus 4ac over 4a squared. And you're done with method of completing the squares. Let's go ahead and look at some examples. Page 3. Now let's note something. The part where we had negative b squared over 4ac over 4a squared. This part, okay? Now this is what determines the minimum value and also the maximum value. Now, we get a minimum value when a in the actual function or in the actual equation is greater than 0. So, yes. And then when a is less than 0, we get maximum values. And then all these values, that is either the maximum value or the minimum value, occur at x equals to negative b over 2a. If you recall, negative b over 2a is what determines the axis of symmetry. Is that okay? Perfect. Let's take some examples. Example 1. We have to find the roots of the equation 2x squared minus x minus 1 equals to 0. Solution. So first you have to write down your coefficients, that is a, b, and c. So our a in this equation 2x squared minus x minus 1 is 2. B is negative 1 and c is negative 1. And then we find, so using the method of factorization, we say you should find AC first. Is that okay? So finding AC, our A is 2 and then our C is negative 1. So we multiply them. That is 2 times negative 1 and gives us negative 2 as AC. After that, we find factors of negative 2. That will sum up to negative 1. That is finding the factors of AC. That will sum up to B. And our B is negative 1. And then those numbers are going to be negative 2 and then 1. Now, when we sum negative 2 and 1, it gives us negative 1. Is that okay? So using these factors, the factors negative 2 and 1, using the factors negative 2 and 1, we substitute them in place of negative 1 in the equation that is 2x squared minus x minus 1. We substitute the factors in place of negative x. Is that okay? Good. So wherever we see negative x, this time around is going to become 2x squared minus 2x plus x. This is the negative 2x, and then this is the x. Is that okay? And then minus 1. This becomes the equation we will have. And then stage 4 or step 4, we factorize and evaluate. So once we have this, we can see some commonalities here. 2x squared minus 2x, we can factor out 2x from here. From this 2x squared and then 2x. That's what we can do. And also x minus 1, 2, we can factor 1 out of it. So let's go ahead. So we put 2x squared and then 2x in the brackets and then put x minus 1, 2 in the brackets. So that we'll be able to factor 2x out of this. Okay. Giving us 2x out and then x minus 1 plus x minus 1. Don't forget we factored 1 out of this. And so there is 1 in front here, but mathematically we don't write that, we ignore. So the factors of this quadratic equation is now x minus 1 and 2x plus 1. Now it is very clear to see the x minus 1 because it is here. All right. Now how come we had 2x plus 1? It's because of this factor 2x and then the 1 in front here. The 1 in front here is positive. Is that okay? So I mean it is plus. So plus 1. That is how come we have the 2x plus 1 over here. So the only two factors that will give us back this quadratic equation is x minus 1 and 2x plus 1. And then we equate them all to 0. Hence, we solve each factor or we equate each factor to 0. Is that okay? And then we find the actual root. So x minus 1 equals to 0, giving us x equals to 1 as one of the roots of the quadratic equation. Or we have 2x plus 1 equals to 0, where x equals to negative half. So the two roots of the equation 2x squared minus x minus 1 equals to 0 are negative half and 1. Let's look at example 2. Example 2. We have to find the roots of the equation x squared minus 2x minus 3. This time, we're going to use the factorization method, but I'm not going to spell out the steps. I'm going to go straight forward and solve. Okay? So we list our coefficients A, B, and C, where we have A equals to 1, B equals to -2, and C equals to -3, which means our AC is going to be 1 times -3, which will give you -3. And so we find factors of -3 that will sum up to give us -2. And these factors are -3 and 1. So when we sum -3 and 1, we are going to get -2. That's correct. And then we substitute these factors into the quadratic equation, but in place of where we have b is -2. So we put that back so that we'll be able to get back -2x. See, if we add -3x plus x, we're going to get negative what? 2x. That's the main idea. Okay, good. So we get back x squared minus 3x plus x minus 3 equals to 0. Then we factorize by using brackets first. Okay, so that we get x squared minus 3x plus x minus 3 equals to 0. Then we factorize the common terms out of each bracket, and then know what to do. So factorizing, we get x out, and then x minus 3 plus, there's 1 here, and then we have x minus 3 again. So the two factors are going to be x minus 3 and x plus 1 equals to 0. Hence, we solve these two factors separately by equating each to 0 to get the actual roots of the quadratic equation. So we have x minus 3 equals to 0, and x will be equal to 3. Or x plus 1 equals to 0, and x equals to -1. Let's go ahead. Using, yes. So example 3, we find the roots of the equation 2x squared minus 3x minus 1 equals to 0. But this time using the method of completing the squares. Okay, let's go ahead. So the same as we started doing with the method of factorization, we list our A, B, and then C correctly. Okay, and then using the method, this is the first part of the method. Okay, but don't forget this equation, this is an equation equal to 0. This is an expression. So whatever we do, we equate that to 0. Okay, so here we said it is A, where our A is 2. So we have 2 here. And then we have inside x squared minus, it is bx over A. Is that okay? Here we are going to have 3x over 2, because our A is 2, minus c over A, which is 1 over what? 2, and it should be equal to 0. Then also, now, because this is equal to 0, it simply means that 2 is equal to 0, and then this whole thing in the bracket is also equal to 0. Now, if 2 is equal to 0, that means 2 can be ignored. And then now we can work with this because it has a variable in it. Okay, so x squared minus 3x divided by 2 minus 1 over 2 equals to 0. And as I explained how this 2 is no more here. Is that okay? Perfect. All right. Now looking at the step 2, that's where we're supposed to halve the bx over a. So it's only the b over a that we're supposed to halve. Is that okay? So that gives us b over 2a. And then we are going to square it. And after squaring, we add and then subtract it to what we have in the bracket. So doing same, here we have it is negative 3 over 2. Is that okay? And if you have that, we are supposed to get negative 3 over 4. And then we will square it and add and then subtract. Is that okay? Good. Then step 3. Step 3. This is where we are going to break it up. Okay. So that we have the x plus b over 2a all squared minus b over 2a squared plus c over a. Is that okay? So relating that to what we have down here, it's going to give us x minus 3 over 4 squared minus negative 3 over 4 all squared minus 1 over 2. Now this time you only compute what we have here so that you'll be able to get back what we had as the negative b squared minus 4ac over 4a squared. Is that okay? Good. So that is what we have here. Now computing the negative 3 over 4 all squared gives us the 9 over 16 minus 12. And that gives us x minus 3 over 4 squared minus 17 over 16 equals to 0. That's the answer. So we move the 17 over 16 to the other side, and then that becomes that. So we have x minus 3 over 4 all squared equals to 17 over 16. And therefore, we square root both sides of the equation. So is that okay? So if we square root what's here, that is the x minus 3 over 4 all squared. The square is going to cancel the square root, giving us x minus 3 over 4. And then that's going to be equal to plus or minus the square root of 17 over 16. That's the answer. And so the answer, yes, plus or minus that. And then we are going to now maintain x alone, which is going to be, now see, it is x minus 3 over 4. So when that also moves, it becomes 3 over 4 at the other side of the equal to sign. So the final answer now becomes x equals to 3 over 4 plus or minus square root of 17 over 16. Now, plus or minus simply means that we are going to have two answers where one is going to be positive and the other is going to be negative. Is that okay? So the first answer is going to be 3 over 4 plus square root of 17 over 16. And the other answer is also going to be 3. Sorry. Finalizing everything here is supposed to give us 3 plus square root of 17 over 4, simply because the square root of 17 over 16 is the same as the square root of 17 over 4. If you recall this topic on sets, or if you have watched my videos on sets, is that okay? Or this. So as I said, it's two ways, that is positive and then negative. So that's what we have there. Let's look at final example. Find the root of the equation x squared minus 6x plus 7 equals to 0 using the method of completing the squares. This time around, I'm not going to use the methods or the steps again. I'm just going to go straight forward and then solve for you. Okay, good. So we list the constant or the coefficient a, b, and then c. And then we do this. So we're going to have x squared minus 6x plus negative 3 squared minus negative 3 squared plus 7. Is that okay? Good. This is because when you find your, yeah, perfect. We have our b being negative 6. Is that okay? And so if you have the negative 6, you're supposed to have negative 3, and then you square it so that you get negative 3 over negative 3 squared. Perfect. This will give us x squared minus 6x plus, in a bracket, negative 3x squared. And then it's going to be equal to, remove the negative into bracket, negative 3 squared plus 7 all to the other side of the bracket. And that gives us negative 3 squared minus 7. So, okay, and this finally gives us x minus 3 all squared equals to 9 minus 7, and then that says x minus 3 squared equals to 2. And then you square root both sides, which gives you x minus 3 equals to plus or minus square root of 2. Move your negative 3 to the other side, which becomes 3. And then you have your answers to be x equals to 3 plus square root of 2, or x equals to 3 minus square root of 2. So this will be all for part 1. We'll meet again for part 2. Thank you.